Hi every student, this one is the last lesson for your chapter 4. That's a 4.4 logic gate. So this one I will discuss about this topic. That's not related with the before that what we learned. So this one's a new subtopic. Okay, let me see what is that. Okay, first one you will see the logic gate, what they're talking about. Okay, you can refer your notes also got. Okay, logic gate, that is a electronic circuit that with a single output and one or more input. So let's see the diagram here. Okay, they just say about single output. So that means later after the logic gate, there will one signal to come out. Okay, they want single output. Okay, maybe your input can more than one or two or three or four. Okay, after pass through the logic gate, that means they just got one information to tell you what is that. Okay, now we see another one. Okay, logic gate as a switching circuit in an electronic system. The logic gate, they perform the logic operation, they're using the binary input. So the binary input, we just got two numbers. That's either 0 or either 1. For the input, we're also using 0 and 1. For the output, also 0 and 1. But normally, 1 is represented by high, or you say 1 means on. Okay, 0 means low, or you say 0 means off. Okay, so this one, the number 0 or 1, depend the situation, they will give you the information about the meanings. Okay, then we go to the next one. Okay, next one means I want to related something about the logic gate. Although you see the 0 and 1, but you must have the truth table or some of the summaries to explain for you. Okay, let's see what is the truth tables. Okay, two tables, that's one summaries of the possible input and output of the logic gate. So that means they want one of the table must summarize. Okay, either 0 or either 1 for the output. Okay, Boolean algebra is a one equation. That's related with the input and output, but there's an in form of the equation. Okay, input then equal output is how many. So later we see what is a Boolean algebra, what is the truth tables. Okay, the following is some of the diagram about the machine. They're using the logic gate to function. Example, the ATM machine. Then we got leaf. Then we got washing machine and also your vending machine. These all they're using the logic gate binary number. Then they go to function. Okay, now we go to the next part. Okay, now I start to introduce the logic gate. Okay, the first one is the AND gate. Okay, remember when you write AND gate, you write the N must be capital letter. Okay, what you need to memorize. Okay, first one, symbol. Number 2, Boolean algebra, or you can say Boolean expression. Okay, third one, table, the truth table. Okay, the last one is a circuit. The circuit is represent the table. Okay, now we're going to see how these four things is related. Okay, first one is a symbol. Then make sure you know how to draw. Flat, after that bend. Okay, now you can see A and B. These two is an input. Then we just got one output, there's an X. Okay, so Boolean algebra, how we write it? We just write X equal. Okay, for the AND gate, we put dot. Okay, A dot B, that one is represent the equation for the AND gate. Okay, now we're going to see the circuit. Circuit is a two switch. Two switch also arranged in series, then joined together with the bulb. Okay, now we're going to see what situation the bulb can be light up. So from this one situation, then you must know both switch must be closed, then the bulb is light up, is it? So this one circuit actually is represented by AND gate. AND gate function exactly same like this circuit. Okay, now we see the truth table. Okay, truth table, we got input, 2 input, 1 output. Okay, you see the number here, 0, 0, 0, 1, 1, 0, 1, 1. So if the question never provide the input, okay, you must memorize. So the memorize must be follow this format. We start with follow 0. Okay, we start with 0 first. 0, 0, then 0, 1. After that 1, 0, then last one should be 1, 1. You do not jump. Don't jump. After you jump, that means the output should be all run already. So we cannot function already. Okay, so from here, remember the sequence, how we go to arrange. Okay, now we see the output X. Okay, output X means when a switch A open, switch B also open, so the output is 0. 0 means the bulb do not light up. Okay, now either A or B, the switch you go to close, the bulb still cannot light up, is it? So what situation the bulb can be light up is when both switch is closed, means 1, 1. When both also close, then last one, the bulb can be light up, so also 1. So this one situation just like you got two friends, A and B, you want to go for a movie. Okay, maybe they ask you want to go or not. Then your result is what? You both must be go, then I join. Okay, either one go, I also don't want to join. So this one is a situation for AND gate. Okay, so now we go to the next one. Okay, next one is the OR gate. Okay, OR gate, when you see the symbol, they got curve at the bottom. Okay, 2 input again. Okay, 1 output. Boolean algebra, x equal, now is a plus. For the OR gate, we write is a plus. Okay, now you're going to see the circuit. Circuit also got 2 switch. Now the 2 switch is in parallel. Okay, just now it's a series. Now it's parallel. So from this one circuit, you go to conclude what situation the bulb can be light up. Okay, first, when both also 0, sure cannot light up. Okay, either one close. A close, okay, no problem, the bulb can be light up. B close, the bulb also light up. If both close, also can be light up. So this one we call OR gate. So from the truth table, you can see 0, 0, there's a 0. Then the rest, either you appear one of the 1, that means output sure become 1. So this one situation is when you go to movie, okay, either one of the friend, either friend A or friend B go for movie, then you will join. Okay, if both go, you also go to join. So this one is called OR gate. Okay, if from here you also can using the equation. If I'm using A, B is 0, 0 means 0 plus 0, your output is a 0. 0 plus 1, so your output is 1. 1 plus 0, your answer also is 1. But 1 plus 1, from here we cannot get the answer, is 2. Because binary number just got 0 and 1. So 1 plus 1 also is 1. Okay, so this one is a truth table for the OR gate. So you must very clear. When I say OR gate, you must think about the situation. When I say about the AND gate, you must think about the situation. So I conclude again, AND gate is both become 1, then last one, your answer is 1. OR gate is either one. Either one, you get the answer is 1. Your output sure is a 1. Okay, now we go to number 3. Okay, number 3 is a NOT gate. Okay, how you know there's a NOT gate? When you see the circle in front. Okay, the circle we join together with the logic gate, the one we call NOT gate. NOT gate just got 1 input. Okay, 1 input, 1 output. NOT gate, the function is to inverse the input signal. So they go to reverse back. So example, if I say A is 0, mean your X must be 1. Okay, they will just reverse. Okay, Boolean algebra, X equal to A, put the bar at the top. You can say they wear the cap. When they wear the cap, one of the bar at the top, understood there's a opposite. Okay, opposite meaning. So when I draw the truth table, 0, output must be 1. Input 1, output must be 0. So the circuit is a bulb and switch parallel. So if I say A is open, that means your circuit must pass through the bulb, then the bulb light up. If I say switch A is closed, that means become 1. Your bulb sure cannot light up. This one is a short circuit. So that means the current just pass through the switch A, then go back. Okay, so this one we call NOT gate. Okay, where they apply to the automatic gate, sliding gate. You go to shopping center, you go to bus stand, they got auto gate, is it? When you just stand there, they got sensor. After that, they will open. Okay, if nobody, they will close it. So they're using the NOT gate to apply this situation. Okay, then we go to the number 4. Okay, number 4 is a NAND gate. Okay, actually the NAND gate, there's a combination. There's a combine with AND and also NOT. So AND and NOT, they join together, we call it NAND gate. So can you see this one symbol? The same like the AND gate, but they add one a circle in front. When I just add one a circle in front means opposite already, is it? So this one situation is totally opposite the AND gate. Okay, now we see the Boolean algebra. For the AND gate, is a x equal a dot b. Now you got none, is it? So you need to put a bar at the top. Okay, let's see the circuit. Okay, the circuit A and B is a series, but both parallel with the bulb. Okay, we see this one situation. When the A open, B open, the bulb no problem. The current can be passed through the bulb, then go on. Okay, if A close, B open, also no problem, they can pass through the bulb. Okay, B close, A open, they also can pass through. But last one, if A and B close, there's a short circuit, that means the current will go straight to A and B, never pass through the bulb, then go back. Okay, so this one situation is actually opposite with the AND gate. Okay, recall back AND gate. AND gate, the situation is both is a 1, then your output is a 1, is it? So NAND gate is opposite. 0, 0, they will become 1. 0, 1, they also 1. 1, 0, they also 1. But 1, 1, they will become 0. Okay, so you don't need to memorize a NAND gate. You just remember the AND, then you take it as an opposite. So if I'm using the watching movie, again the story, this one situation is when the couple, they just invite you go to for movie. So that means either one go, you also will follow. If the couple go, that means you don't want to follow. You don't want to become a spotlight. So that's why this one is called NAND gate. Okay, just when both become 1, then you are become 0. So this one is an example for the NAND gate circuit. Okay, either the switch just on, that means the NAND gate can be function. Okay, if both also on, that means you cannot function. So this one is a NAND gate truth table and also the summaries. Okay, then we go to the last one. Last one is a NOR gate. NOR gate is a combination OR and NOT. So can you see the symbol? OR gate symbol plus one circle in front. Okay, remember the circle must be touching the logic gate. If the circle far away, that one not related. Okay, so this one is an OR gate. OR gate Boolean algebra, there's a A plus B. Okay, if you put one bar at the top, mean there's a NOT. You add one NOT. So there's an opposite opposite the OR gate result. Okay, let's see the circuit. AB parallel, bulb also parallel. Okay, now we see how to function. If I say AB open, anything happen? Yeah, the bulb can be light up. Okay, if I A close, the bulb sure cannot light up because the circuit, they become short circuit already. The current straightforward pass to the A and go back. Okay, if B go, that means also same. They go to the B, finish. If A, B close, sure they also cannot pass up the bulb. Either one they will go. So from here the situation is opposite the OR gate. Okay, recall back the OR gate. OR gate is either one become 1. So your output must be 1. Okay, so this one is reverse. If anything is 1, I must 0. What situation I become 1? There's a 0, 0. That means when A and B is open. So you can see the truth table here, 1 or 0. So the final answer is a 1000. So that's why I call A, B, you must follow the format. If you change the format, that means output, we cannot remember already. Okay, what's the pattern? So from here, we just continue the story. The story now is what? Nobody go, then I will go. Okay, either one you go to movie, I also don't want to follow. So this one like enemy lah. Your enemy just go movie, you don't want to follow. So you want to alone. You go alone. Okay, so this one we call NOR gate. Okay, so now I want to give some example about the logic gate. So combination, then we need to answer. Okay, let's see the first one. This one is A, B is an input. So I give you the input already, the number 0, 0, 0, 1, 1, 0, 1, 1. Okay, now you need to fill in is a P, Q, and Y. Okay, we're going to solve the P first, P and Q first lah. So the Y should be the last one. Okay, now we're going to see the P. P, there's a come from where? Okay, P, there's a come from the A, is it? A pass through the NOT gate. Okay, pass through the NOT gate means P totally opposite the A. So I can write, I just see the A only and B no need to see. 1, 1, 0, 0. If the A is 0, P will become 1 because they pass through the NOT gate. Okay, how about the Q? Q just refer to the B. Okay, Q is here, then refer to the B. B pass through the NOT gate will become Q. So Q just opposite the B. 1, 0, 1, 0. Okay, now we're going to see the Y. Okay, this one is not related. I say you must touching here. If never touching means we just ignore. Okay, now this one is Y gate. This one is AND gate. Okay, recall back AND gate. AND gate, the situation is both 1. Then the answer is 1. Okay, now we check. PQ only, no need to see AB. 1, 1, yes. The rest, 0, 0, 0. Okay, so this one is an output from the Y. The same like the NOR gate. Okay, now we want to write Boolean algebra. Okay, Boolean algebra normally they say Y equal how many is it? Okay, Y equal how many? Okay, so I need to write, okay, Y P, this one is an AND gate, and is a dot, there's a Q. Okay, actually this one answer will not accepted because input must be AB, cannot say PQ. PQ is a middle one. So we need the answer is AB and Y only. So we sub the one by one. P actually is A bar. Q actually is a B bar. So we join together. Y is how many? Y is a dot B then bar. Okay, agree. So this one is the answer for the Y output Boolean algebra. Okay, then we go to the next one. Okay, the next one, there's a combination. There's extra one more. They got R, S, and also Y. Okay, A, B is the input number. Okay, 0, 0, 1, 1, 0, 1. Okay, now we go and write this all thing. Okay, first one we go to the R. We need to check input R is from where. Okay, input R, they're from the A. They also from the B. Okay, A and B. Then go to the R. R is what gate? R is a NAND gate. Okay, R is a NAND gate. Okay, so from here we think about NAND gate. NAND gate is opposite the AND. Opposite the AND means the situation is 1, 1, 1, 0. That one is opposite the AND. Okay, now NAND gate. So from here 0, 0, then will become 1, 1, 1, 0. So this one is a couple. Couple, just go you want to go. Okay, now we go check about S. S come from the, okay, S is come from the R. Okay, okay, no, not related R. There's a B. Okay, B straightforward go to S. A also go to the S. So that means from AB. Okay, S is a OR gate. OR gate means either one. Okay, either one is 1, then you also must be 1. So this one is a S. Okay, last one, Y. This one is an AND gate. Okay, AND gate must be both also 1. So this one is 0, 1, 1. This one is 0. So this one's the final answer. Okay, Boolean algebra, we write one by one first. R is come from the A on, not, there's a dot B, okay, A dot B. Okay, then you put the bar. Okay, now we go to the S. S also A plus B. Okay, A plus B, because there's a OR gate. Okay, last one, Y. Y actually come from the R and S. R dot S, because there's an AND gate, is it? Now I need to combine. I don't want R and S, I want A, B only. So R is how many? R is A dot B bar. Then your dot S is how many? A plus B. So this one is the final answer for Boolean algebra. Okay, final answer just got Y and also A. Okay, I think this one is no problem. Then continue for the example 1 from your notes. Okay, so this one is example 1. Okay, the figure, the question, they will show you the table. If it's more easier, you show the table and let you to see more easier. Okay, now they put two input P and Q. Okay, now they give you the P. So this one question they provided. They provided the input number, then you just follow. Okay, now you can see this one is what gate? This one is a NAND gate. No, this one is a NOR gate, not NAND, because they got curve. So this one is a NOR. Okay, NOR the situation like this. This one is a NOR gate. Wait, this one NOR gate. Okay, this one is a AND gate. Sorry, this one not OR gate. This one is what gate? This one is a NAND gate. Okay, so I think this one wrong already. Don't follow this part. This one wrong already. So must be, if I change, become the NOR gate. So become NOR gate. Suppose is 1 0 0 0. Okay. Okay, NOR gate. So we think about NOR gate. Okay, now we go and check the answer here. Okay, NOR gate 0 1 should be 0. 1 1 is 1. Sorry, 1 1 is 0. Okay, 1 1 also is 0. This one NOR gate, the situation is enemy. You don't want anybody to follow you, you just alone. So from here, this one also is 0 0. Okay, this one you will go 0 and 0. So this one is the answer 3 0 1, then followed by 2 0. So this one you call it, that's a NOR gate result. Okay, we go to question number 2. Okay, question number 2, the situation like this. Okay, this one situation actually is what's the meaning. Okay, V vote 1 means this one means 0 0, because there's a nothing, there's a 0 vote, is it? So we take this one as a 0 0. This one is 1 1. Okay, this one means 0 1 0 1. Okay, this one is for the bar. So from here, this one input. Okay, you prepare the table. The question never provide the table. You better prepare the table because so many sub, you cannot straightforward get the answer. So from here, we just fill the blank. Okay, A is 0 0 1 1. B is 0 1 0 1. Okay, now we're going to see the C. C is a NOT gate. They just come from the B, is it? Okay, this one not related. This one is just crossover. Okay, so there's a B. Okay, you just reverse the B. There's a C. Okay, then we check the D. D is AND gate. Okay, they come from the A and come from the C. So we just see A and C. B no need to see. Okay, 0 1 AND gate, there's a 0. 0 0 0 1 1 1. Then this one 0. Okay, so we go to the E. E is come from the A and B. Also is an AND gate. So AND gate is a 0 0 0 1. Okay, last we're going to check about the X. X is a OR. Okay, we just see D and E only. O means 0, 0, 1, 1. Okay, so this was the answer from the example 2, 0, 0, 1, 1. Okay, if the question calls you to draw, then you need to draw lah. Okay, draw like this. When starting 0, then you dotted. Draw the dotted box. Okay, after that 2 more is a complete. Then you draw the complete. So this one is the answer. If the question calls you to draw. This one is V, this one is a X. The final is a X. Okay, then we go to question number 3. Okay, question number 3, they provide a table and also provide the input and input. So you just follow lah. Okay, from here, I just write the answer. We don't need to discuss already because we know the pattern. Okay, first one is NAND gate. So NAND gate is a 0, 0, 0, 1. Okay, D is a O. O means like this. Okay, last one is a X. X is what? NOR gate. Okay, NOR gate is an enemy. So that means this one is a enemy is anybody just go, you don't go. Okay, so this one is the final answer. Okay, then we go to the question number 4. Okay, question number 4. Question number 4, they ask about Boolean algebra. So you need to write. Okay, this one question never provide input. So you need to write yourself. The input is how many? So I call you to memorize already. So you need to put 0, 0, 0, 1, 1, 0, 1, 1. Okay, let's check the R. R is come from the NOT gate. So this one is check X only. The Y no need to see because they're from the X. 1, 1, 0, 0. Okay, S. Okay, S is here. S is come from the Y. Okay, after I go to NOT. So you just reverse the Y. That's the answer. Okay, T. T, there's a O. They come from the R and come from the Y. So you just check R and Y. Okay, this one is OR gate. So 1, 1, 0, 1. Q, the last one. Last one is a NAND. NAND, you're going to see S and T. NAND, the citation is couple. Couple go, you don't want to go. Okay, 0, 1, 1, 1. So the final answer is 0, 1, 1. Okay, algebra. Okay, algebra, we one by one first. R come from the X, so there's an X bar. Okay, S. S, they come from the Y, there's a Y bar. Okay, how about T? T, there's R and also Y. So there's R plus Y. Okay, S, finish. Then we go to the Q. Q is come from the T and S. T dot S. Then we need to bar, is it? Because there's a NAND gate. Okay, now I want to combine. T actually equal to the bar X plus Y. Agree? Okay, Q. Q actually, we can put already lah, all the thing we put together. Bar X plus Y. Okay, you can put a bracket. Okay, dot. S is it? S come from the Y. Bar. Okay, totally, finally, you put the bar together. So we check, is it correct or not? Okay, X bar plus Y dot Y bar, then totally bar. Okay, so this one's the final answer for Boolean algebra. So I write here, bracket, X bar plus Y, then bracket, then dot, bar of the Y. Okay, now I need to bar overall. Okay, so this one is a Boolean algebra for question number 4. Okay, so you can check it. Then we go through is number 5. Okay, number 5. Okay, number 5 also the same thing. They never provide any input. So you just write yourself the input is 0, 0, 0, 1. Okay, so I straightforward go to apply. Okay, R is a NOR gate. So NOR gate is an enemy. Enemy means don't want to follow anybody. Okay. Okay, S is a NOT come from the Q. 1, 0, 1, 0. Okay, the X. X is what? X is an AND gate. So AND gate we check about RS 1, 0, 0, 0. Okay, so this one's the final answer. Okay, Boolean. Okay, Boolean, I change the color first. Okay. Okay, the Boolean we one by one to check. R is P plus Q. Then you put the bar. Okay, S is from the Q bar. Okay, how about the X? X, there's an AND gate, R dot S. Okay, now I want to combine. Okay, we combine final answer just P and Q. So from here, X equal to the P plus Q. Okay, bracket, you put a bar. Okay, dot Q. Q also got bar, is it? So now you can join the bar actually. P plus Q, Q dot the bracket dot Q. Okay, now totally you can put the bar at the top. So this one is a final answer for answer question number 5. Okay, so you can write here P plus Q bracket dot Q also, then you put the bar. So this one is a final answer. Okay, simple is it? So we continue to the example 6. Okay, example 6 also same. The question also asks about Boolean and also never provide the input. So we write the input by yourself. So I think no problem already after you do some of the exercise. Okay, we just write. Okay, S from the NOT gate, there's a... Okay, we straightforward go to R. R is a NOR gate. From the S and also the Q. So the NOR gate means the enemy. Okay, 0, 1, 0, 0. Okay, so this one is your answer. How to write the Boolean? So we just write the S. S from the P bar. Okay, how about the R? R is from the S plus Q. Then you put a bar. So now I need to join. P, put a bar. Okay, then plus the Q. And also overall we got bar at the top. So this one is a final one. Can remember, don't forget this one cannot join because Q never have the bar. So we just write P bar first plus Q. Okay, you can put bracket, then overall also bar. So this one is the final answer for question number 6. Okay, now we go to the 7. 7, also the same thing. Just fill in the blank for the input. Okay, let's see the S. S is a NAND gate. NAND gate, they come from the Q. Okay, this one situation means the Q they separate by 2. If Q is 1, both also 1. If Q is a 0, both also is a 0. So from here, P and Q. So from here, we find it. This one is a NAND gate. So NAND gate is a couple. So from here, this one is a 1, 0. Okay, sorry. Terbalik. So this one is a 1. Okay. This one also is a 1, 1, then 0. Okay, T. T is a NOT gate. Come from the Q. We just reverse. Okay, last one is a R. R is an AND gate. So AND gate must be both also 1. 0, 1, 0. So your answer is 1, 0, 1, 0. Okay, Boolean. just do the calculation for the S. P dot Q bar. Okay, T is Q bar. Okay, R is S dot T. Okay, final R equal P dot Q bar, pull a bracket. Okay, then you dot Q also got bar. So both I can join. So final answer here, bracket P dot Q, bracket back Q. Okay, both also got bar and I can bar together. So this one is a Boolean algebra for the question number 7. Okay, then this one should be the last example question. Should be the same also, fill in the blank. Okay, let's see the P. P is a N, so N. Okay, Q is opposite the P. Okay, I fast already. Then the R is a OR gate. OR gate is a 0, 1, 1, 1. Okay, last is a C. C also is a OR gate. OR gate means 1, 1, 1, 1. So the final answer, OR is a 1. Okay, Boolean, then we need to write the P equal A dot B. Q equal, I can straightforward A dot B, you put a bar. Okay, R. R equal A plus B. Okay, so your C actually is a Q plus R. Okay, now I want to join back. C equal, Q is how many? A dot B bar, bracket, plus R is how many? A plus B. So this one is a final answer. So I write here, A dot B bar plus A plus B. Okay, so this one is a Boolean algebra for the question number 8. Okay, so we're going to see some application for the logic gate. Okay, this one they apply for the automatic fan for cooling system. We need to conclude this one's logic gate actually how to function. Okay, so from here we got light detector, we got temperature. So that means you detect the light and also temperature. Because the question never tell you 0 represent what. So we just assume lah. 0 means there's a day. Okay. Then the temperature, 1 means high temperature, 0 means low temperature. Okay, so depends light detector. So you detect the light, there's a 0. If you never detect the light, there's a 1. Okay, sorry, opposite. If you detect the light, means there's a 1. If you never detect the light, there's a 0. So we just write here sum of the info. Okay, 0 means day lah. Okay, 1 means night. Okay, so this one is temperature high, there's a 1. Okay, temperature low, there's a 0. Okay, so the fan, 1 means on, 0 means off. Okay, we see this one, they're using the AND gate. AND gate means what situation the fan will on. The situation must be night. Okay, and also the temperature high. Okay, the fan will automatically on. So the other situation, the fan also cannot be on. So this one is an automatic fan cooling system. Okay, we go to the next one. Okay, this one is one of the example. We're going to check this one how to function. Okay, we see the NAND gate first. NAND gate is a couple. So either one just on, they also can be on. So you check this one. Okay, you see when both also on, the NAND gate is cannot on. Okay, so now either one. Okay, now I off. Both also off, the NAND gate also can be on. Okay, I on one, the NAND gate also can be on. Okay, so from here, this one is a function for the NAND gate. Okay, now NAND gate both also on, so that means the NAND gate cannot function. Okay, now we see the AND gate. AND gate, the situation must both also must be on. Okay, now you check this one. One red, one white color means AND gate cannot function because here no green color. If both also off, there's sure no green color. Okay, now I on all the thing. AND gate, now you got green color. Okay, now last one should be the OR gate. OR gate is either one. So you see, when the NAND gate is green color, okay, the fan can be turned. Okay, either one. Okay, now we're going to check this situation. Okay, both also green color, they also can be turned. Okay, now AND gate is on, NAND gate on, AND gate off. They cannot. They also can be moved. Okay, now this situation, no green light. That means the fan will stop. So finally, must be depend for the OR gate. Okay, OR gate means either one you can switch on. That means the fan can be function. Okay, we go to the next one. Okay, so this one is an application for the fire alarm system. They got two things: smoke detector and heat detector. Okay, smoke detector means they're using the OR gate, can trigger the silent. So what situation we can trigger the silent? Either one. You can detect the smoke, then the silent will activate. Either the heat detector. Unless both is zero, that means nothing happened. Okay, then we go to the next application. Okay, this one is application for the control system. Okay, this control system, they're using two logic gate. One is an AND, one is an OR. They got two output, two different output. Okay, two different output, because one logic gate just can one output. So we got smoke detector, we got heat detector. AND gate for fire distinguishes. For the OR gate is a fire alarm. So fire alarm, what situation we can detect? Fire alarm is either one. Either you got smoke, either you got heat detector, fire alarm will be on. So you can see the result. Zero means both also zero. So either one you can detect, the fire alarm also be triggered. But fire extinguishers, they just function when both also on. That means you can detect the smoke, you also can detect the heat, then the fire extinguishers, they will be on. So this one situation is depend the system how you go to design. Okay, then we go to the next application. Okay, this one is a control system for the street light. So this one is normally you pass by, you can see they got light on or off. Okay, for this one situation, you can see about the switch and also light sensor. Okay, we got two things. Okay, you can see the light sensor. Okay, light sensor here they put one of the NOT gate. Okay, you see what conclusion about this control street light. Okay, when the switch is zero, light sensor. Okay, they sensor the you got any light to sensor, then the street light can be one. Okay, when the switch is closed, then the sensor is nothing. The sensor can be sensor one, then the street light will be off. Okay, when the switch just open, okay, light sensor, I don't care you sensor 0 or 1, the street light must be on. Okay, I can make one conclusion is as the switch on means 1 lah. Okay, the street light sure on. Okay, so this one is first conclusion I get it. Okay, when the switch you just on, sure the street light will be on. Okay, another situation is when the sensor, light sensor, okay, is 0. Okay, I don't know 0 is what situation. Okay, then your street light, okay, also on. Okay, we check, is it? Okay, you see the light sensor 0, they become 1. 0, they also become 1. Okay, then the switch, when you just switch on the switch 1, sure, this one, the street light must be on. So I just can conclude like this only. So you can depend, you see the situation for the design. Okay, so this one is one of the example. Okay, you see, during the morning they off the light. Okay, during the 7 o'clock they're on. Okay, until the early morning 7 a.m. they're off. Okay, this one is depend the light, some is depend for the time. So I think this one is the last part for our lesson. So from here, after this one explanation, I think it's no problem for tutorial 4.4. So thank you for watching. Hope you can finish at 4.4. Then I will discuss about tutorial 4.4. So any question you also can be PM me. Okay, thank you.